Okay. Now, so at this stage, as at the diplonema substage of the prophase 1, each chromosome is made visible, or we can see it as two visible sister chromatids. Also, each chromosome, here you have the maternal and the paternal chromosome. Each one of them, we can start to see two chromatids for each chromosome or so. Okay, so each chromosome is made of two visible. We can see that each chromosome is made of two visible sister chromatids. So we can start to see that we have two chromatids in each of the DNA. الصوت مش واضح؟
عم بقطع.
لا دكتور صح.
طب رح كفي، إذا عم بقطش ارجعوا قولوا لي. أوكي. The diplonema stage is very long in the human oocytes. In fact, the oocytes will get arrested once they are formed. The meiosis will start in them. We are going to see in the chapter of the female reproductive system, and in this chapter also, later in this chapter. Once they are formed, the meiosis will start, but they will get arrested at the diplonema of the prophase 1, and they will remain arrested for a very long period of time. They can still stay arrested to 40 years, for example. Okay. The oocytes that will be activated later or chosen later to for in each menstrual cycle. As you know, in each menstrual cycle we will have one oocyte that will continue, or one follicular, one ovarian follicle that will continue its growth. Okay, so only the oocyte of those ovarian follicles will continue their meiosis, will resume their meiosis. However, the others, if at the menstrual cycle and after puberty they are not, they won't enter they are not activated, and they are not the chosen one for the menstrual cycle. They will remain arrested at this substage of the prophase 1. Okay, so the human oocytes can be arrested at this substage for very long periods of time. Now, during the diplonema in the human oocytes, the chromosomes will decondense also at some regions. Okay, we will have a decondensation of the chromosomes. And why this decondensation is important? Because, as you know, if we need to have a transcription of the DNA into mRNA, we need to have the DNA in its decondensed form. Okay, we cannot have a transcription. So in the oocyte, during this phase, we have a decondensation of the chromosomes at certain points, because this will allow the synthesis of messenger RNA and ribosomal RNA, which are necessary for the production of proteins and the constitution of protein stores necessary for the maturation of the oocyte. For in this stage, the cell will constitute its protein store necessary for steps of the zygote segmentation. Okay, so this is during the diplonema that we will have in the oocytes decondensation of the chromosomes at certain point, which will allow the synthesis of messenger RNA and ribosomal RNA, the synthesis and the consequent synthesis of proteins necessary for later steps of the oocyte maturation and for the fertilization and for the zygote segmentation. Okay. And due to this increase in the synthesis of messenger RNA, ribosomal RNA, and for the increase in the protein stores, we will have an increase in the diameter of the oocytes at this level of the prophase 1. So the oocyte will increase in size or in diameter at the diplonema of prophase 1 due to the increase in the content of messenger RNA and ribosomal RNA and in the protein stores also. Okay. This is regarding the diplonema. Now, as we said here, the chromosomes, the homologous chromosomes, will remain attached by the level of the chiasma is diakinesis. هلا ماشي الحال.
دكتور أنا ما سمعت آخر شي شو قلت.
يلا لحظة. بعرف.
بعده عم يقطش.
في لك قصدك ساينبتونيما. Okay, I will repeat a little bit. يلي ما سمعوا هون I was saying that the oocytes will remain, and we call it also the diprotein substage of the prophase 1 for prolonged periods of time. And in the oocyte, the chromosomes decondense at certain points. Okay, and this condensation will allow the transcription of the DNA
Doctor,
to synthesize. Yes. حدا عم بيقول شيء؟
لا ما حدا عم يحكي.
دكتور فيكي ترجعي تعيدي الدايبلونيما باختصار لأنه كتير كان عم بيقطش.
ما كنت عم بعيدها بس طولوا بالكم شوي يعني. The diplonema, as we said, here we have the synaptonemal complex will start to disappear. Okay.
دكتور عم تحكوا شيء؟
راح
صوته.
Okay, during the diplonema, we will start to see two separated threads or the homologous chromosomes separate, okay, but will remain attached at the chiasma points, okay. So the synaptonemal complex will disappear, but we will only keep on having those homologous chromosomes attached at the level of the chiasma. So they will not completely separate, okay? They will keep on being attached at the level of the chiasma. We will have more condensation and shortening, and then we will have a shortening and thickening of the chromosomes, and we can start to see that each chromosome is composed from two sister chromatids. Okay. Now, however, this stage, the diplonema substage of the prophase 1 is very long in the human oocytes, because those oocytes can be arrested, or they will be arrested at this diplotin stage for long or very long periods of time. Okay. And in the human oocytes, during the diplonema, the chromosomes will decondense at certain regions, and this decondensation will allow them to produce or to synthesize messenger RNA and ribosomal RNA, because, as you know, only the uncondensed, if the DNA is very condensed, we can't have the transcription, okay, of the DNA into RNA. So in order to have the synthesis of mRNA and ribosomal RNA, we should have a decondensation of the chromosomes, which will happen at certain points of the chromosomes to allow the synthesis. And this synthesis of mRNA and ribosomal RNA is important to the production of proteins necessary for the later steps of oocyte maturation, and for the fertilization, and for proteins necessary also for the zygote segmentation. Okay. So in this step, we can generate stores of proteins necessary for the coming steps of the oocyte maturation, and for the fertilization and the zygote segmentation. And so during this diplonema substage in the oocytes, we will have an increase of the diameter or of the size of the oocyte due to this increase in the synthesis of mRNA and ribosomal RNA, and due to the increase in the stores of proteins. Okay. Now, the last substage of the meiosis is called the diakinesis, and this means moving through. In this step, or in this final substage of the prophase 1, the chromosomes will condense further. So we will have them at their maximal condensation during the prophase. They will condense further, and the telomeres detach from the nuclear membrane, so they will get separated. We don't have them anymore attached at the nuclear membrane. Okay, they will be detached from
دكتور مش عم نسمعك، عم بيقطش كتير خط.
the
دكتور مش عم نسمع.
دكتور ما عم نسمع ولا شيء.
طيب هلا أحسن؟
هلا طلع الصوت.
هلأ طلع الصوت.
وين آخر شي سمعته يعني؟ الدايكاينيسيس سمعته؟
هلا لما
لا دايكاينيسيس ما سمعنا شيء.
طيب. The last substage of the prophase 1 is the diakinesis, and it's called so because it means moving through. We will say, what does it mean? Now, during the substage, the chromosomes will condense further, and if they were a little bit uncondensed, like in the oocyte, they will recondense, okay? So they will condense further. They will separate from the nuclear envelope, okay? They will not be bound anymore to this nuclear envelope because the nuclear envelope will get degraded and will disappear at this substage, and also because they need to attach now in the pro-metaphase after this, directly before the metaphase, to the mitotic spindle, or sorry, to the microtubule spindle. So they should detach from this nuclear envelope. They will get detached from it, and the nuclear